Okay, so in this problem, we're given this point, -1, 2, and told that it is on the graph of a function f. And what does that mean? That means that f of -1 is equal to 2. So this is what we're given, this is what we know, and then we're asked to determine a point on, or asked which points we can determine conclusively are on the graph of y is equal to negative f inverse of f inverse of x. And so this may look a little bit scary because there's all these f's and f inverses everywhere, but it's actually pretty straightforward if we really understand what's going on with inverses, the inverse relationship. So we're assuming that f is invertible, that it'll be invertible everywhere. This is kind of a background assumption. For the details of that, you can of course check out the rather lengthy videos where we go into a lot of detail on what it means for a function to be invertible. But when a function is invertible, what it means is that f of f inverse of x is equal to x, which is equal to f inverse of f of x. And this is for first of all, x would be in the domain of f because it's coming in there, right? And then so f inverse undoes f basically, right? X goes into f, and f inverse peels that f off, and we just get the x. Same thing, f undoes f inverse, right? When I apply f to f inverse of x, I get x back. So this is the key. This is the key relationship that allows us to solve this problem. And again, sort of breezing over a lot of stuff here, but it's all on the inverse videos about domains and codomains and ranges and everything. What's the point about this is that I can then take this. I can take this y is equal to negative f inverse of f inverse of x, and say, all right, well, I know from this relationship that we have here that f inverse of, or f of f inverse of x is just going to be x, right? That those two will undo one another. And I can use the fact that I know from up here, f of -1 is equal to 2, right? So what does this mean? This means that f inverse of 2 is equal to -1. And we get this from that first piece of information that comes from knowing that -1, 2 is on the graph of f. F inverse of 2 is equal to -1. And so what can I do? I can plug in. Let me move this down to get a bit of space. I can say if I want to find an x y pair on the graph of this function, negative f inverse of f inverse of x, well, let me take the x is equal to 2. Why? Because I know that if I plug that in here, I know what f inverse of 2 is. It's going to be -1. So I can say negative f inverse, I'll write that a little bit more nicely, negative f inverse of f inverse of 2, with the right number of brackets, I think, is equal to negative f inverse of, well, I know that f inverse of 2 is -1, so this is f of -1. And I know that f of -1, again up here, is 2. So this is negative f inverse of 2. And then I know that f inverse of 2 is -1, just applying this again. So this is negative 1, which is equal to 1. So I know that the point 2, 1 has to be on the graph of this function. Alternately, I could use that same inverse relationship to say, all right, well, what's f of f inverse of x? Well, f inverse undoes x, and f undoes f inverse. That's the whole point of inverses. So this is actually negative f inverse of x, right? These, and the brackets should maybe be kind of the same size. Negative f inverse, there we go, of x, right? Because f of f inverse of x is just x, same as f inverse of f of x is just x. They undo one another. And And then so again we can say, because we know one point which is definitely in the domain of f inverse, right? Again, this is what we got at the beginning. F of negative 1 is 2, so negative 1 was in the domain of f, and f inverse, this is the same thing as saying f inverse of 2 is equal to negative 1, so 2 has to be in the domain of f inverse. That is a point that we know is in the domain of f inverse, so we'll take x is equal to 2, and this will be negative f inverse of 2, which is negative, we know that f inverse of 2 is negative 1, so again, negative 1, which is just 1. And that is another way that we can get the point 2, 1 as the point that we're looking for on this graph. We know for sure that will be on the graph. And so again, just to sort of recapitulate, the whole point of this is to get us to realize that we have this relationship, which is that x is equal to f inverse of x, and this is for any x in the domain of f, and similarly x is equal to f of f inverse of x for x in, and actually maybe I'll do y for this instead. Probably should have been doing this from the beginning, but just to show that we have this thing, right? F going from some place to some place, and then f inverse goes back from there to the other place. And again, there's a bunch of details about that, which you can check out the invertibility videos for, but I just want to sort of make it clear that the domain of f is not necessarily the same as the domain of f inverse, right? The domain of f inverse is the range of f, and the domain of f is the range of f inverse. So yeah, maybe y is a little bit better. And this one is for y in the domain of f inverse, which is the range of f, and the domain of f is the range of f inverse. And I think that covers all the bases. So that is how we do that problem, and that is why we can solve this problem. That's what this problem is trying to get us to realize or use.